Usually, when a tech billionaire tells you they are going to save humanity, you have to roll your eyes so hard it hurts. But Elon Musk is different. He is frustrating. He is often childish. He tweets things that would get a mid-level manager fired from a darkly lit Arby's. Yet he is also the only person in the last 20 years who has managed to build both an electric car company that didn't go bankrupt and a rocket company whose rocket actually goes to space. So, when he points to a giant stainless steel silo in a swamp in Texas and says it is going to take us to Mars, you have to stop rolling your eyes and start taking notes. In this show, we decided to be the adults in the room and ask the hard questions. Is this real? Can it actually fly? Or is it just another expensive toy for a man who has too many of them? To answer that, we have to ignore the noise. We have to ignore the fanboys who think Musk is the Messiah. We have to ignore the critics who think he is a fraud. We must examine the metal. We have to look at the math. The vehicle is called Starship. It is the biggest, loudest, and most ambitious flying machine humans have ever tried to build. It is designed to be an airliner and a meteor at the same time. It is trying to do something that the laws of physics really do not want it to do. This show is a deep look at the engineering reality of the Starship. We are going to look at the nuts and bolts. We are going to look at the welds. We are going to look at the terrifying math of the rocket equation. Buckle up. It is going to be a bumpy ride. Let us be clear about what we are looking at here. Starship is not just a rocket. It is a two-part beast designed to break every rule in the aerospace handbook. The bottom half is the booster. It is called Super Heavy. It is 70 meters tall. It is basically a flying fuel tank with 33 engines on the bottom. Its only job is to heave the top half out of the thick soup of our atmosphere. The top half is the ship itself. It is also called Starship, just to make everyone confused. This 50-meter-tall vessel is designed to transport cargo and is capable of landing on other planets. Together, they are 120 meters, or about 400 feet of gleaming stainless steel. Here is the kicker. Musk wants to reuse both of them, not just once. He wants to reuse them rapidly. He wants to fly them, land them, refill them, fly them again on the same day. He compares it to a Boeing 747. If you threw away a jetliner after every flight, a ticket to London would cost $1 million. We only fly because we reuse the plane. Musk wants to do that with rockets. It may sound straightforward, but in reality, it is incredibly, perhaps even impossibly, difficult. The current approach to rocketry is highly inefficient, bordering on absurd. Launch vehicles are typically expendable, burning up after a single use, a practice as wasteful as destroying your car after one trip to the store. While SpaceX successfully demonstrated the reusability of the Falcon 9's first stage, the second stage presents a far greater challenge. Recovering a ship from orbital velocity around Mach 25 means it slams into the atmosphere, creating intense, steel-melting heat, making the re-entry and recovery process exceptionally difficult. So why do it? Because if you can reuse the whole stack, the cost of putting a ton of cargo into orbit drops from thousands of dollars to maybe $100. It changes the math of space. It allows you to launch massive telescopes that do not need to fold up like origami. It allows you to build a base on the moon. It allows you to go to Mars. But first, you have to fight the physics.
Yeah, we've got this weird situation in space where vehicles can only be used once.
Space travel is ruled by an unforgiving law known as the rocket equation. Derived over a century ago by Konstantin Tsiolkovsky, it dictates the fundamental limits of what is possible with chemical propulsion. The equation describes a vicious cycle. To reach orbit, a rocket must accelerate to a velocity of nearly 8 kilometers per second. To achieve this speed, it must expel mass out the back. This reaction force pushes the rocket forward, but the fuel itself has mass. To accelerate that fuel, the rocket needs even more fuel. To accelerate the extra fuel, it needs yet more fuel. It is a compounding debt spiral. If you want to launch a satellite, you need a giant rocket underneath it. If you make the satellite a little heavier, the rocket does not just get a little bigger, it gets a lot bigger. This is why rockets are mostly gas tanks. On the launch pad, Starship is about 90% propellant by weight. The structure, the engines, the electronics, and the payload are just a tiny sliver of the mass. Now add the reusability problem. If you want to bring the rocket back, you need landing legs, you need extra fuel to slow down, you need heat shields. All of that is dead weight on the way up. The rocket equation hates dead weight. It punishes you for it. Every kilogram of heat shield you add is a kilogram of payload you cannot carry. SpaceX is trying to cheat this equation by making the rocket enormous. They are using brute force. Starship is so big that even with all the heavy reuse hardware, it can still haul 100 tons to orbit. But it puts them on a razor's edge. They have to save weight everywhere else. They strip the ship down to the bare metal. They run the engines at insane pressures to get every ounce of efficiency. They are fighting for every gram because the physics taxman is always watching. Think of it like packing for a vacation. But for every pair of socks you pack, you have to pack a second suitcase just to carry the socks. And then you need a bigger car to carry the suitcases. And then you need a tanker truck to fuel the car. Pretty soon, you are not going on vacation. You are just managing logistics for a convoy. That is rocketry. Staging is the only way out. You burn through the fuel in the first stage, and then you drop the empty tank. You shed the dead weight. That is why almost all rockets have 2 stages. Starship does this too. But because it wants to bring the empty tank back home, it cannot just drop it in the ocean. It has to fly it back. That requires fuel. That requires control surfaces. That requires grit. People look at the success SpaceX had with the Falcon 9 and assume Starship is just a bigger version. That is lazy thinking and wrong. Falcon 9 is dependable and predictable, much like a Toyota Camry. It is a proven workhorse whose capabilities are fully understood. In contrast, Starship is an immense vehicle with extreme performance, a semi-truck with the power of a drag racer. Falcon 9's booster landings are impressive. However, the second stage is routinely discarded, burning up upon atmospheric re-entry. Starship aims to retrieve this second stage from orbit, a feat that presents a significantly greater engineering challenge. The speeds are different. The heat is different. The energy involved is an order of magnitude higher. Also, the scale creates new problems. When you make something twice as big, it does not just get twice as hard to handle, it gets 4 times or 8 times as hard. The problem of vibrations is enormous. Compared to the Falcon 9's 9 engines, Super Heavy has 33. The combined acoustic energy from all 33 engines firing simultaneously is powerful enough to break concrete, which was evident during the first test flight. That flight was chaotic. The rocket basically excavated a massive hole and subjected its own engines to a barrage of rocks. It was a disaster. They had to rebuild the launch pad with a massive water-cooled steel plate just to keep the rocket from destroying the ground it stood on. That is a problem you do not have with smaller rockets. Then there is the fuel slosh. You have a tank the size of a building filled with liquid methane. If that liquid starts sloshing back and forth, it can throw the rocket off course. It is like trying to balance a tray of drinks while riding a unicycle, except the tray weighs 1,000 tons. So no, this is not just a big Falcon. It is a completely new engineering challenge. SpaceX is learning the hard way that size matters.